At this point, we have seen how PayFlow runs. We have looked at the infrastructure, the application, how changes move into production. The next step is not to start fixing things immediately. The next step is to understand where the real risk actually sits. Because in systems like this, not everything is equally important. Before I access risk, I want to anchor us on the current system again. This is still the same PayFlow setup we have already seen. Users are coming through engines. Requests are distributed to two application servers, and both of those depends on the shared PostgreSQL database and Redis. At a glance, this is still a fairly understandable setup. The question now is not whether it was, the question is where it becomes fragile. I usually break system down into a four core risk area. Number one being release risk, how changes get into production. Number two is operational risk, how the system is managed day to day. Number three being system risk, how the architecture behaves under load or failure. Number four being visibility risk, how well you understand what's happening in production. If you understand these first, you will understand most production systems. Let's start with release risk. This is the architecture of change inside PayFlow. A developer writes code, pushes to GitHub, a build happens manually, and then the release depends on the ops engineer connecting directly to a production server. This matters because the deployment part is not controlled by a repeatable system. It's controlled by human execution. Technically, that creates a few problems. First, there is no guarantee the same sequence of steps happens every time. Second, both application server can drift during deployment. One might get updated before the other. One restart may succeed while the other behaves differently, and now production is temporarily running mixed states. Third, rollback is not built into the path. If a release goes wrong, recovery becomes another manual process layered on top of the first one. So release risk here is really change inconsistency, not just failed deployment, inconsistent deployment. In this system, change is not yet deterministic. Next, being operational risk. This is not about servers. This is about who hold the system together day to day. In PayFlow's case, most of the operational responsibilities sit with one ops-minded engineer. Tasks include deployment, infrastructure changes, production access, and often the first line of incident response. The problem with this setup is not that the engineer is bad. The problem is that the system now depends too heavily on one person's availability and knowledge. So if that person is unavailable, overloaded, or simply makes a mistake under pressure, the operational capacity of the company drops immediately. It also means core platform knowledge is not distributed across teams. That slows down onboarding, makes troubleshooting more dependent on memory than process, and increases burst factor. The platform is not only coupled to infrastructure, it's coupled to a person. Now, let's look at the system risk. Inside PayFlow, the business domain are logically different. Authentication, wallet management, transfer, transaction history, notification, admin, or operationally, they still live inside one deployable application. That means the runtime boundary is shared. From an engineering perspective, this creates tight coupling in two places. First, at the application layer, a release touches the entire monolith, even if the change only affects one small area. Second, at the data layer, everything depends on the same PostgreSQL instance, and much of the request part also depends on Redis. So the system risk is not simply monolithic bad, it is that the blast radius of failure is broad. A change in one part of the application can affect unrelated flaws. A slowdown in the database affects the whole platform. A cache issue affects more than one business capability. Business domain are separate in logic, but not separate in runtime behavior. Now, visibility risk. This is one of the most underestimated problems in growing system. Right now, logs are mostly local to the machine. Monitoring is basic. Alerting is limited. So when something goes wrong, there is no some standard operation picture of the platform. That means debugging becomes fragmented. The ops engineer may need to inspect one app server, then another, then check what the database was doing, then try to reconstruct the sequence manually. So incident response becomes slower, not only because failure happened, but because the system does not explain itself clearly when they do. In practice, that means some problems are discovered through customer complaint before engineering sees a meaningful signal internally. This system can fail faster than the team can understand why. So once I've looked at PayFlow through those four lenses, the priorities becomes clear. System risk is real, but not the first thing I will attack. The highest immediate pressure is in the release risk, operational dependency, and visibility. Why? Because those three determine whether the team can safely change the system, respond when something goes wrong, and actually trust what they are seeing in production. If I can't deploy safely, if operational knowledge is concentrated in one place, and if I can't see the system clearly, then larger transformation work becomes harder and riskier. So before designing architecture, I would first stabilize how this environment is changed and operated. So before introducing new tools or architecture change, the priority is to stabilize how the system is operated. Because right now, the system is not failing because of complexity, it's failing because of how it's been handled. And that's where we start.